All right, just a reminder that you need to, everybody, even if you're on this Google Meet, needs to do the attendance for today. And if you weren't a part of the meet yesterday and know about the lesson, you'll need to watch that Google Meet because you have to put one thing from yesterday's lesson in this attendance box here. Even when we start back Monday, we're going to do attendance this way. This is sort of going to be like our warm-up in class. And so this is how attendance will be. Tomorrow, you'll do attendance for tomorrow the same way, and you'll put one fact about the lesson that we did today in there for that. Those that actually put the accurate facts or facts there, you earn extra credit points for the end of the semester. We are in meteorology still. Today we're going to talk a little bit about air masses and air fronts. And I went ahead yesterday and gave you a wind web quest, but notice it's actually due today. So if you haven't finished it, you're going to work on that today. And I want to glance at it just a minute to remember exactly what it is, because what I was trying to put for your next assignment repeated some of this. So I want to look at it real quick. All right, so it started out with that. It did have the global winds, the Coriolis effect. All right, and then that extra credit part. All right, and yesterday did have an extra credit section. That's totally up to you to do part 4, but you have to do parts 1, 2, and 3. Part 4 is extra credit. You have a website link to go for each section. I just wanted to make sure that I knew what I was going to do for the next thing. Today I just have a couple videos for us. I'm going to talk through a little PowerPoint. And then besides working on that wind web quest, you are going right here from yesterday. I've got 2 videos here. Tomorrow I'm going to have a couple more videos and then a web quest that will go along with all these videos. And I will probably pre-record something on severe weather that you will need to watch. So there are assignments on Remote Friday. So next week on Monday, just to get announcements out of the way, we come back to school face-to-face Monday. Tuesday, due to voting, is a remote day, so there will be assignments up. There will not be Google Meetings during the day for that day, but there will be assignments up. Wednesday will be B group unless you come every day, and Thursday will be B group unless you come every day. And then Friday is another remote day where there will be assignments, but will not be Google Meets, live Google Meets being held. So that's sort of next week. So I want to slip over here. We're going to talk a little bit about air fronts, and try to make this a little bit bigger here. So kind of air masses and air fronts. So we talked about wind, I believe, a little bit yesterday, but wind is what's going to be driving. It's the force that's going to move air masses. And air masses are just a large mass of air that has the same pressure and usually the same temperature. They have the same characteristics, and they're going to form over areas. So typically you have cold air masses up around the Arctic. You can have cold air masses where this green area is, and then around the equator and a certain area above and below that, you're going to have air masses as warm air masses. And so we're going to kind of look at some of these different air masses here. So air masses you're going to describe them kind of in 2 ways. They're going to either be dry or moist. So if they're dry, that means they formed over land. So we give them the name continental. If they are moist, they formed over water. And so we give them maritime, a name for maritime, and we abbreviate that with a little c and a little m. And so the maritime ones are going to carry lots of moisture. Then we also have temperatures. So you've got tropical, which is going to be abbreviated little t, and they're going to have warm air, and polar, which is going to be a p. They may be capital. These are capital initials. Cold air, and then you've got the Arctic, which is the coldest air. And so it's going to depend, the temperature depends on the area, if it formed close to the equator or close to the colder areas of the globe. So to kind of put it in a chart here, tropical, you can have two tropicals. You can have CT, which is continental, or MT, which is maritime tropical. So you can have a warm air mass that formed over land. You can have a warm air mass that formed over the ocean. So you need to know what these mean here. Polar, this is continental polar. It formed over cold land. Maritime polar over cold water. And then Arctic, there's only one. It's continental, and it comes from the Arctic area. You're going to have a map that's kind of like this and what you're going to do tomorrow, and you're going to have to label these. So notice from the North Pacific, you've got the maritime polar. From the South Pacific, you're
Sorry, I'm
fine.
late.
The South Pacific, you have, please mute yourself, you have the maritime tropic. From here in central United States, you've got continental tropic, so it's going to be a warm, dry air front or air mass. And then here through the Gulf and from the southern Atlantic here coming up, you're going to have maritime tropic. And then from the northern Atlantic coming into the northern part of the U.S., you're going to have the maritime polar. You're going to you're going to need to label a map similar to this so you can refer back to one of the videos or back into this Google Meet if you need help, if the website doesn't help you when you get to that tomorrow. All right, fronts. Where these air masses meet is called a front. And so typically along a front, your warm air, which is less dense, is always going to be forced upwards. So you've got four types: warm, cold, stationary, and occluded. You've got to be familiar with the weather that each of these brings and sort of the symbol you would see on a weather map. Um, a warm front will occur when warm air is is moving into an area that is already covered by cooler air. And so what's going to happen, so the warm front is moving this way. There's cold air already there. The advancing warm air is going to be pushed upward above the cold air, and you're going to have a lot of clouds developing, and you're going to get long, steady rains. And so notice this symbol right here. The warm front is going to be red, and it's going to have the half circles on it, and that's going to be the symbol for a warm front. So here's sort of an example of a warm front again. It's coming in, it's moving up, and you're getting cloud coverage. Here's another example, where you see the warm front being used. Okay. Not right now. You're going to have to look later. Not right now. Cold front. You can do it while I'm doing my lesson. Don't interrupt, please. The cold front then is when it is advancing in an area. Um, the cold air is more dense, and it's quickly moving into an area that is warm. It already has warm air. And so what this is going to happen is going to cause thunderstorms. This is when we have our huge thunderstorms. It's usually cooler afterwards. So this receding cold air, which is going to be forced upward, is going to meet that warmer air. That's going to, all the moisture is going to condense. It's going to build up in these tall, towering cumulonimbus clouds that we talked about earlier, and your thunderstorms will form. And notice that blue triangles are on a line is what the symbols are for cold front, and it points the direction it moves. So we're going to look at a couple examples here. Here is the cold front. Notice the little animation up there. You've got warm air, and the cold air is approaching the warm air and pushing up, and it's when we see these huge towering clouds like this that are usually dark, and we get thunderstorms. On a weather map that you might see on TV, here's the cold front again, the symbol for it. Stationary front is interesting. It kind of goes by its name. It's stationary. You have fronts that are not necessarily moving. They're kind of parallel, and the at the boundary, it's like they don't really move. You're going to have mild precipitation. You're going to have red and blue symbols alternating, and so they're kind of sliding past each other, and it's not going toward one another. So that's sort of a stationary front. You're going to see that like this on a real live map. Here is an occluded front. Cold fronts can move faster than warm fronts. Stop. Carol Ann, I'm teaching. Get what you need. Take care of it. Let me teach. Shh. All right. So when you have an active cold front that overtakes a warm front, it's an occluded front will form. And notice you've got the fronts are going in the same direction because the symbols are on the same side. You're getting cloud development here, and you kind of you're going to get typically heavy rain, and so they're going to be they can be purple semicircles and triangles, or it may be alternating blue and red. So this is sort of an occluded front, and we're going to see here in a real live map that here it's purple, and here they have them together instead of alternating. So it really depends. They'll be on the same side if it's an occluded. It'll be alternating if it's stationary, and it'll be all the same if it's a warm or cold front. So here's what a weather map may look like. And we're going to do something next week with weather maps. We have a high pressure system here, low pressure system. I believe we talked a little bit about the closer the lines, the more windy, I believe we said it was. Then you've got these lines here that connect lines of regular pressure. You can also have lines that connect the same temperature as well. So we'll get more into weather maps later. So that's sort of an overview of the air masses and fronts. You've got a video on each of those if this loads up. Masses and weather front, hurricanes and tornadoes, and your other web quests to do. And that'll be due on Monday. The videos will be due tomorrow. And then we're going to look at a little bit about weather mapping and the symbols you see, and then we will be finished with our weather unit. So we'll be testing at the end of next week. That's pretty much what our lesson is today. Does anybody have any questions? And if your internet was going in and out, the video recording will be up later on this afternoon, and you can watch it. So any questions on anything that we've done today, this week? Is everybody good?
Yeah.
Okay. Um, so I'm taking everybody's good. Miss Morton, do you have anything to say to the boys before I dismiss?
Just that if they need help with anything, just email me, and I have that my Google Meet today at beginning at 2:30, and I'll be on till 3:30. So if they have any questions or need my help, then they can log in during that time as well.
Okay. And again, you can always email me, message me, let me know. But if you have not turned in work, you need to be getting that done. I have quite a few zero averages for this 9 weeks, so we need to make sure we've gotten work done, and that's not necessarily geared toward you guys that are on. It's geared to the whole class because hopefully others will jump on and listen to the recording. You've got, don't want to get behind because we're going to keep moving forward. We still have several more units to get through. So if there's no questions, I'm going to stop recording. Sounded like somebody undid. Timothy, you got a question? Are you good?
No.
You're good? All right, I'm going to stop recording.
Yeah, I'm good.